All right, so welcome again. All right, so in today's class, we will do something different. Um Last time we started with the very basic elementary mathematics, and today I will touch the little bit of algebra, which is my personal favorite. So I will be trying to make the balance between the elementary mathematics, algebra, and then eventually calculus. All right. So what we are going to see today here. Okay. So our aim is today is to solve system of linear equations by substitution method. Okay. By substitution method. Okay. So here by this time, you know what are the linear equations you have dealt, how to plot the graph, how to investigate the nature, so on and so forth. But today I'll give you something a little bit more further ahead. So if I say I want to solve the system of linear equation by the substitution method, means you have to focus on the keywords here. Okay. So substitution method means literally a dictionary meaning of the substitution means the replacing one thing for the another. So that's the simple English meaning of the substitution, which you already know. And since it says that the system of linear equations, so I must be having more than two equations. Okay. Now I'll give you an example. Okay. So 3x plus 5y. So 3x plus 5y is equal to 6 and y is equal to 2x. Okay. I always have a habit of labeling the equation. It is not mandatory, but it becomes a very handy when, I mean, if, let's say if you make mistake somewhere, it will be easier to trace the error. But up to you. Okay. Now, you see here, I want to substitute here. I have y is equal to 2x, so I can substitute whatever you are from the equation 2 in the equation 1, and you see how the equation 1 will be coming. Okay. So 3x plus 5, 2x, and 26. So 3x distributive property over here, and it goes 10x is equal to 26, 13x is equal to 26. Divide both the sides by 13, divide both the sides by 13, x is equal to 2. All right. So I got x is equal to 2. I label it as number 3. But I want to find out the y as well. So what I will do, so I will substituting the value whatever of x, which is negated from the equation number 3, again in any one of this equation. But you know that equation 2 is very straightforward, and if you use equation 2, there is a less hassle for the algebra, okay, for calculating y. So I will use this. So y is equal to 4 and drop down. Okay. So now, but don't forget to write the solution xy is equal to 2 and 4. This is the solution. Now, this is as far as the algebra part is concerned, and probably you know everything over here. The only one point which I want to highlight here is that what is the meaning of this point? Okay. The meaning of this point is when you plot these two lines, on the graph, they will pass through this unique point, or in other words, 2, 4 is the point, is the ordered pair which lies on any one of this equation. Okay, so we should know why we are doing this and what is the physical meaning, what is the interpretation lies behind it. All right, so enough said. Practice. 2x plus 5y is equal to 7, and x is equal to -1 minus y. All right. As usual, I will label them. And of course, not necessarily that in the first part we solve it for y. Now here we will substitute for x. So 2 minus 1 minus y plus 5 y is equal to 7. Distributive property. So minus 2y plus 5y is equal to 7. Combining like terms together, y is equal to 7 plus 2 plus 2, y is equal to 9 divided by 3 divided by 3, y is equal to 3. Okay, so here I got the solution for y, and of course I'll make use of that. I will substitute y is equal to 3 in equation 2 to get the value of x. So x is equal to -1 minus of 3, and x is equal to -1 minus 3, x is equal to -4. Done. Okay, but don't forget to collect the result as xy, because this is a unique point, right? Ordinary ordered pairs, and that is the solution for the part 2. Okay. After this, I will take another problem, which is number 3, and okay. So here is 2x is equal to 4 minus y, and 5x plus 3y is equal to 10. Okay. Think over it. What I can do, pause this video, uh, try to come up with the solution, and if not, of course, you can have a look. So in this number 3 example, life is not that easy, right? So if you see here, if you try to solve out the x, so what will happen? X will get solved, no doubt, if you can divide both sides by 2. But then what will happen is that x is equal to 4 divided by 2 minus y divided by 2, and it will unnecessarily involves the fraction. And then you are going to use it over here, and already the problem is a little bit tougher. Why you want to make it life more easy, difficult, right? So what I will do, if I investigate this equation properly, I will see that I will take y to this side. What do I mean by that? So 2x is equal to 4 minus y. So plus y plus y. So 2x plus y is equal to 4. Now I will subtract -2 from both the sides. I made my life easy here. Minus 2x plus 4, and I will do it as this 3. Okay. Now this problem is ready to solve. Now I will substitute again. Substitute equation 3 in 2. Okay, and let's see how the corresponding changes are. So 5 minus 2x plus 4 plus 3y equals 10. Don't forget to use distributive property, collecting like terms. Oh, sorry, my bad. It is reverse and happens in the other way around. Sorry. Should be. So 5x plus 3 minus 2x plus 4 is equal to 10. So you got to be careful. You don't want to repeat minus x. minus 6 plus 12 is equal to 10. Collecting like terms, 12 is 10 plus 12 minus 12 minus 6 is equal to minus 2. And you divide by minus 1 and x is equal to 2 is the solution. Okay. So x is equal to 2. I will make substitute this. I'll substitute this. Where can I substitute? I can use it in 1 or number 3. Okay, number 3. Y will be minus 2 times 2 plus 4 minus 4 plus 4 is equal to 0. Okay. Yeah, I hate this. After doing so much, the answer 0. Let me check whether it's correct. Yes. So, and don't forget to club the answer as ordered pair as 2 and 0. Okay. Now, what you have learned here is you have learned to solve a system of linear equations, because you know the degree of polynomial is 1. So we started with a very basic and a simple example where x and y are straightforward, ready to substitute for them in the other equation. You learn that. After that, you know if the things are not friendly, you made them friendly and you did it over here. So before I close this, I would like to discuss one more particular example and then we will close. I don't want to take your too much time. So number 4. Okay. Generally, I use this example to test the concepts and have a look. So 4x is equal to. So what happens in this equation? X is pretty straightforward. I can substitute for x. I can substitute for x directly in equation number 2, and let's solve it. Okay, and let's see what are the changes. 5 minus 2y plus 4y is equal to 6. So distributive over here. 10 minus 4y plus 4y is equal to 6. And if you chop out y is gone, and then you'll end up with 10 is equal to 6. Something is wrong, right? Is 10 is equal to 6? No, false. So probably then what happens is that there is an option that okay, you want to retrace your steps. Did I make something wrong here? No. Did I make something wrong here? No. Did I am I using the correct data? Yes. So then why I'm landing up with this such a weird situation, and what is that meaning of that? If you land up in such a weird situation, so what you do is to first solve for y. Okay. So look at the equation number 1. X is equal to 5 minus 2y plus 2y plus 2y. X plus 2y is equal to 5 minus x minus x. 2y is equal to minus x plus 5. Okay. I'll divide by 2 entire things. Y is equal to minus x over 2 and plus 5 over 2. Okay. Now I will solve second equation. Okay. And before that second equation, minus 2x. So okay, I don't mind. 6 minus 2x minus x. 4y is equal to minus 2x plus 6. And of course, divide by 4, and y is equal to minus x over 2 plus 3 over 2. Okay. So why did I do this? When I solve the system of linear equation, when I use the substitution method correctly, I'm landing up with such a weird situation. And then I want to find out the solution. So then what I do, I started investigating the equations. I solve it for y in the standard y is equal to mx plus b format. And I started looking the properties here. But if you look here, m is the slope. And if you look here, is this, okay? So if you see that both the lines have same slope. Same slope means the lines are parallel. And if the lines are parallel, they do not intersect. Why would they intersect, right? And since they do not intersect, you cannot get solution for a unique solution for x and y. Okay. So when you plot, you come to this situation, you plot it systematically. You come to know that okay, so the slope is same. That means the lines are parallel and they are not going to intersect. So that is the solution for this problem. And I think that's too much algebra for today. Okay, so of course, your comments, suggestions, welcome. If you know any better method, let me know. I will improve mine also. And remember one thing, don't work hard, work smart. Okay, so I will stop here and let me know what do you think. And ta-ta.